We hope you have fastened your seatbelts and are ready to dive deep into the exciting world of science, technology, and innovation. Our speakers have harnessed the unknown to innovate and to catalyze progress. So, ladies and gentlemen, to introduce our speakers, please welcome Bahariah Bahadom, Senior Vice President, Strategy at Khazanah Nasional.
Ladies and gentlemen, this year's theme challenges us to flip our perspective, to see risk not as a roadblock, but as fuel for resilience and innovation. Uncertainty has always been part of the human journey. The question isn't whether risk exists, but how we choose to face it. Do we freeze like the grasshopper or adapt and thrive like the ant? Innovation without borders isn't just about ideas. It's about embracing uncertainty, mobilizing capital, and unlocking solutions that cross geographies and sectors. That is the heart of today's session. Innovation has never been risk-free, but time and again, it has proven to be risk-worthy. From hyperscale data centers powering the digital backbone, to venture networks building ecosystems, to AI reshaping cities, and breakthrough turning plastic waste into clean energy, these stories show how risk becomes the spark for progress. To take us through this journey, we've brought together 4 incredible minds, each breaking boundaries in their own way. Let's begin with our first speaker, Hossein Fateh, President and the CEO of Cloud HQ. Hossein is a true pioneer of the global data center industry. After co-founding DuPont Fabros Technology and selling it in 2016 for $7.8 billion, he went on to launch Cloud HQ, now a leading hyperscale developer with more than 5,000 megawatts in the pipeline. Through Cloud Capital, his private equity arm managing $4.8 billion in assets, Hossein continued to shape the backbone of our digital economy, making sure that as innovation grows, the infrastructure to sustain it is ready. Get ready to hear how AI and cloud are fueling an unstoppable wave of demand and how Hossein and team are building the digital backbone that will carry us into the future. Ladies and gentlemen, please welcome Hossein Fateh.
And where's the pointer? Okay, and how do I go forward? It's not working. Oh. Okay. I want to start here. Hi, everyone. I'm Hossein Fateh. I'm CEO and President of Cloud HQ, Cloud Capital, and founder. Thank you so much for inviting me. I'm here to really talk about where is all this data going and how big really it is. Well, it's massive. This market is growing so rapidly that when people ask me, when is this stopping? At the moment, the only thing holding us back is we don't have enough power. That's where it's going. And it's really, you have to think about it. People blame data centers for all the power usage. This power is not my power. This is your power. It's your children's power. It's your business's power. That's where it's at. I mean, try taking the phone away from your 18-year-old daughter. Well, mine wouldn't have it, and nor would yours. And it's really in the cloud computing. It's really in social media. It's the data of that country. I had arguments in the French government when they say, you Americans are coming, bringing your data here. No, I explained to the French politicians, this is not my data, this is your data. They're like, well, Uber's here. Yeah, but Uber is benefiting you here. This is not Uber America putting its servers here. This is Uber Paris putting its servers here. And frankly, it's making our lives more efficient. In London 30 years ago, you had to stand in the rain for a long time to find a black taxi. This 2 weeks ago, you can get a taxi immediately, whether it's Uber or the black cab at. So it is making our lives much more efficient. Now, where is all this data going? I'm going to go back a slide. It really started, you have to think about technology and internet speeds and where things were and where things are going. In the early 2000s, we were building smaller data centers. At the time, we thought it was massive. It was 13 megawatts of IT load. And we had Google and Yahoo in there competing for the search wars. And Google was, at the time, when I first met them, they were a private company. And I really didn't know who they were at all. But when I spoke to the CFO, and I found out how much money they were making, I almost fell off the chair. I told the CFO, only pay me half rent, pay me the rest in options. Well, he said, last month, we have just stopped doing that. So in 2006, I met Facebook and social media. Again, I was surprised. They needed 2 megawatts of IT load. And I thought to myself, 2 megawatts of IT load for a company that is a college dating site. How is that even possible? And I didn't get it. Well, now I do. We are now, I believe, one of Facebook's, or in fact, the largest landlord of Meta in the US. Next, as internet speeds moved up, you have fiber to the house. Every time fiber to the house means we have Netflix, video streaming. You have kids playing Fortnite. My son, who at the time was a young teenager, was playing with his cousins in Beirut and his other cousins in Los Angeles. But why is that significant? It's significant because Epic Games, the owner of Fortnite, makes over 3 billion of EBITDA a year selling virtual clothes. But it's real income. So it's really changing the way the internet is changing, and internet speeds, as they go up, they change the way we and our children are living. We may not go to the movie theaters as much, but we may watch more Netflix. At the same time, 2013, as things came up, in 2013, it was the advent of the public cloud. What is the public cloud? I'll give you like 2 or 3 examples. The first example is, when we had our emails prior to 2013, many of us, our emails were in our office, on the back of the kitchen. There was a storage, there was a rack, it was an Exchange server. Our emails were in that Exchange server. Then around 2013 came along Microsoft 365. Our emails moved from the back of the kitchen to a data center. What happened in that scenario? A typical modern data center, depending on if we have water or don't have water, spends about 25 cents for every dollar of electricity cooling it. The emails Exchange server on the back of your kitchen in the office is about 1-to-1. So it became much more efficient. Also, that Exchange server worked with other Exchange servers. They all worked together. So it became much more efficient. And then what is also the public cloud? Here at Khazanah, I'm not sure if you use a software called Aladdin. Aladdin is a money management software. 70% of the world uses it. It belongs to BlackRock, but it's hosted on Microsoft Azure. That that software needs to be within a certain distance of, and we'll get to that at a later time, of the availability zone. So you at Khazanah, if you're using Aladdin, you're not going to allow Aladdin to be functioning here from a long distance away. You need latency. So in many times, these data centers need to be close to the public. So as another example, I met Charlie, who you're going to hear from later. She has a company that processes in KL traffic patterns by looking at phones and various things. Her software, I talked to her earlier, is hosted on a hyperscaler that is local. So this is all your data that is going on. In 2013, 14, we started to get Google Maps and geopositioning. When Google Maps and geopositioning came together with 4G, we started to be able to have Uber, Lyft, Airbnb, applications where as internet speeds increased, we were able to find things on our phone and make things much more convenient. And so when you first thought about geopositioning, the company, the US government, and started to release that data to everyone, no one had the idea of how to put these things together. But as internet speeds went up, those types of things started to get invented by Travis, the founder of Uber. Similarly, now as internet speeds went up, things became bigger and bigger and bigger. I'll give you some examples later. But now, since about a year ago, is the advent of AI. And with AI, you have two functions. You have AI training, and you have AI inference. And we are at the very beginning of it. It literally has just started. Many of you, I listened to some of the speeches earlier, and Sir David said, okay, he doesn't think that AI will be able to replace a human. But in some instances, what I'm hearing is not such. What I'm hearing right now is in another conference in San Francisco is that the best AI right now is in mathematics, in biology. It's similar to a diploma and a graduate student. It's at that level, around 12 or so percent. Gets those questions right of a graduate student. Now, recently, it just solved the PhD problem, but not all the time. We believe that in the next 5 years, the most complex mathematical problems, it's not going to solve your rationality, but it will be able to, in the next 5 years, solve the most difficult mathematical problems at a level of a PhD candidate. And so it's changing extremely rapidly. And we don't know where everything is going. 10 days ago, I was in Los Angeles, and we sat in a Waymo, right? In a Waymo, it drove itself. And it was actually kind of aggressive. And there was another Waymo that pulled in front. Our Waymo didn't get way to the other Waymo, so the other Waymo stopped and it went forward. So I think it has an aggressive button or scale, depending on cities where it's at. And I guess in Los Angeles it was more aggressive. In Istanbul it'll probably be extremely aggressive. So But you don't know how these technologies and how people use them. There's a rumor in San Francisco that young lovers, instead of getting a hotel room at night, may book a Waymo. It's a little bit cheaper. So but did Google, who owns Waymo, did they think that that would be a possible application? No. That new applications come along as times change and as internet speeds increase. And so I do want to, hold on, I do want to talk about and a little bit explain, because the common question that I get is that computers are getting smaller and smaller, Hossein. Why do we need bigger and bigger data centers? And where is that going? Because the buildings are increasing, and I'll give you an example of the size of the buildings. I did the biggest deal in the world in 2001. It was Hotmail for 3.5 megawatts of IT load. That was the single biggest deal in the world. That deal was in my building that was in Ashburn. It was in an Exodus building. It took me 15 years for that deal to go increase by a decimal space. I did the next deal 15 years later, in 2016, 35 megawatts of IT load. So now, in 2018, I did a 72 megawatt deal. In 2019, another 72 megawatt deal. In 2024, we did a 300 megawatt deal. So now I'm doing a gigawatt deal. So it took 15 years to move a decimal space. It took 8 years to move another decimal place. And now, since 2024, I think my deal will be finished in 2026, it's again gone 3x from 350 or so megawatts to a gigawatt. And the only reason my 300 megawatt deal did not go to a gigawatt at that time is that we ran out of power in that location. So Moore's law dictates, Gordon Moore is one of the founders of Intel. It dictates that processing power will increase every 2 years or so. And it doubles every 2 years. So if that's happening, why are we needing more and more data center space? Well, the first fact of the matter is they should have measured the number of calculations per second over the number of watts, because that is happening, but the servers are becoming more and more power intensive. The second reason is what we are, here. The demand that us as a society are putting on these servers is actually growing at a pace much faster than Moore's law. And so our business at Cloud HQ and any other data center space is that we are taking the space in the middle. So if we did not continue to use more and more power because of all these industries that I just talked about, I would be out of business, because the hardware technology would catch up to the demand that we're putting on our servers. So that is making, and it's unstoppable. It's where my understanding is training of the AI world can be anywhere. The US companies as such have not left the US in training. In reality I don't think they necessarily trust foreign governments to giving their AI training to those foreign governments. Now, my understanding is OpenAI may go to the UK, but I haven't seen the deal yet happening in outside of the US. So but we also understand that 1 megawatt of training can be 5 to 10 megawatts of inference. Inference is when we talk to AI. And so that is going to be much more data center intensive. So do we give our power? Where do we give our power? Where do we use it? Is of national importance, of using it where we need it for national importance. The amount of processing that is going on in the servers itself is also significant, in that a typical rack in a data center used to be in 2001 around 3 kilowatts. Today, it's gone to about 12 kilowatts a rack. The new Microsoft liquid cool technology, Meta liquid cool technology, is about 20 kilowatts a rack. The new NVIDIA chip, the current NVIDIA chip is 150 kilowatts a rack. The Blackwell chip coming in is 250 kilowatts a rack. And last week, I heard a gigawatt a rack. So it's absolutely enormous. So what's going to happen to the data centers is we are not in the business of selling space. We rent our data centers per available kilowatt at the wall. And we promise to cool it. So rents are calculated as per kilowatt per month of available power, whether you use it or not. So in a sense, a 10 megawatt data center that today may have 1,000 racks in it, in 3 years, it'll have 100 racks in it, but they will be consuming all the power. Okay, thank you.